Here's something that I think is promising. I have a beam that is fixed at the left end here in the wall. There's a roller at the right end, so we call that the propped cantilever. It's subjected to a uniformly distributed load, and what I want to do is determine where the plastic hinge forms in the span of the beam. And I want to do it without algebra, of course, and I want to use the modern Muller Breslau method. So what I'm going to do is look at different cuts and investigate the force that induces the plastic moment. So now let's think about this for a second. The plastic moment is a given. It depends on the material properties in the cross section. The hinge formed by the load is the one that just causes plasticity, and then the interior hinge is larger than the one at the wall here because of the geometry of our problem. So what I do is I break up the load to an equivalent concentrated load on either side of the kink, and then I look at the loft of the beam on either side of the kink in line with the concentrated load. And the loft, of course, is the difference between the original beam position of the load, and the original position of the final position of the load. All right, so now let's look at the angles really quick. When the cut is halfway along the beam through geometric truths, the interior angle is twice the angle of the wall. But that is not the case for other cuts. So you could see here the interior angle, is smaller, and then eventually even smaller still. And notice that the load magnitudes are changing on either side of the cut. But what I can do, and this is pretty amazing, I think, is I can say, well, and the numbers don't really matter here. What I'm looking for is the minimum force per unit length. A force per unit length minimum. All right, so now, and remember the span is 2 here. The span is 10. So I'm cutting it at 2. Now it's at 1.8, 1.6, 1.4, 1.3, 1.2, 1.1, and that looks like about the minimum right here. And that's at 5.8. 7/12, right? 7/12. And that is the theoretical answer, which is pretty crazy cool. So I think this is a nice way of doing it, and I think I could even make a trace of that, which would even be cooler.